And do you like sit onto the spot that you are in last class, or can you choose where?
You can choose where.
Okay.
That's where you sat. Is also fine.
Okay.
How do we tell that we're over 60 characters and
When you upload it to Canvas, then open it in Canvas, you'll see if something wraps around. If something wraps around,
Okay.
go change it. That's what the 60 character limit is really preventing, is the wraparound. And it's just convenience for me to make it harder to grade. It's actually a Canvas problem. Canvas should. Question?
Are we allowed to use else statements?
Null statements.
Else. Like,
Else statements, no if else.
Are we allowed to?
Sure. Oh, you mean if and then else and then make the argument of the else another if? Is that what you mean?
No, I mean.
But yes, you're allowed to do that too.
I don't know if I'm allowed to use the word else because the statement's not in it.
Yes, you are.
Alright, I'll just find it. Class starts at 6, right? Okay, I got confused because I saw everyone here.
Well,
We're here because we're the last letter.
But yeah, I got nothing better.
better to be early rather than late.
Yeah.
Usually if you're late enough, I won't let you know. All right, good evening.
Good evening.
When I call your name, raise your hand and say here. Before we do that, math. Hopefully you all saw the thing that masks are no longer required, but they are highly encouraged. Your words, I just use the word encouraged, but they are highly encouraged. The reason is because it's still frozen over. I know way more about this virus than I want to. I was in the Pfizer study. The vaccine they just approved, that is Omicron specific, I got 2 months ago, or maybe it was 3 months ago. I got it in June, however many months ago it was. That's probably why, but my wife came down with COVID, I did not get it. So it's still prevalent out there. If it's still you, if you're fully vaccinated, you have a really good chance of not dying. Okay. What's your name? Raise your hand, say here, please. Anybody's name I did not call? Okay, now if there's a seat next to you, please raise your hand. An empty seat next to you, please raise your hand. Okay. All right. Few brief class rules before we get on to the real subject of teaching. The college requires me to drop anybody who is not participating. Participating is defined as 1, being here, and 2, turning in the lab assignments. As of earlier today, there were at least 3 people who had not turned in any of the first 3 labs. If that is the case at the end of Friday, probably Saturday morning, Friday midnight, which for me is probably going to be Saturday morning, you will be dropped. Okay? Even if you're here, if you have not turned in those homework assignments, you will be dropped. There were at least 3 of you, 3 people. And they may not have shown up, and they may be none of whom I'm talking to. Okay. Only submit exactly what the assignment says. Exactly, right? Don't add additional operations. Don't add on to previous assignments. New assignment, sir.
I always put in the comments on the top what the instructions are, so I don't have to like go to another page for that. Is that fine?
The comments are fine.
All right.
Remember, your code should largely be self-documenting. But if you want to put comments, I have no problem with comments, right? Never a problem with a comment, well, as long as the comment is correct, but I I don't read your comments, so I literally won't be reading them and grading them. I'll grade your code. So, but it's fine putting comments if you get in the practice of doing so. If some aspect is not specified, that means it's up to you. If I say send a message to get input from the user, that means the wording of the message is entirely up to you, for example. Okay? So I just said send a message. I didn't say what the message should say. But if I say the output should be, the output better be that. But I don't usually say that. I usually care about the content, not the format, right? In other words, if I say assign a variable 10 and then output the variable, I expect to see 10 come out and I expect to see the code reflected correctly, not with a literal 10, but from the variable in the printf statement correctly specified, as some of you discovered in the labs I graded. I've graded all the labs that were due Thursday, Friday, and Sunday. Actually, I've graded everything that's due right now. There have been a few late submissions I haven't gotten to. Just so you know how I grade in order of submission. If something is submitted late, I'll grade on-time submissions even of subsequent labs before I circle back and pick up the late submissions. You have an exam 2 weeks from tonight. Okay, 9/14, exam 1. We haven't covered everything on the exam yet, but hopefully, if I get through all this tonight, I'll be amazed. But we'll see how far I get. Right? A lot of this will just be reviewing and expanding what we've already talked about. Some of it will be very complex stuff. How computers work. In the introductory course, that should be a prerequisite for this class, but I don't think it is. They should tell you all that. I get people in data structures who have no clue how a computer works. It's important to know how a computer works, in the general sense. You don't need to be down at the transistor level, but you need to be at the module level. And we'll talk about that tonight. And I have to talk about that so that you'll have the basis to understand how pointers and references work, which is part of that, even though I didn't write it down, it's written down here. Okay, the way exams work. So we'll do some lecture tonight. We'll finish up the lecture for this exam on 097, the week before. And then we will actually review the material. I'll go through the material that's on the test. This will be everything that we've covered up to then. And just run around the class asking people answers for things. It's not exactly from the exam, it's from the material. The exam is closed book. There's no open book exams. You have to know what you're doing. Because none of this is terribly complicated. If it was terribly complicated, I'd let you use your book. Or other reference, but it's not. And then, the day of the exam, everybody will have a chance to ask one question. Maybe two. It depends on how much time we have. With this many people in the class, roughly 70, there'll probably be one question per person. So, the key to that is, before you get into this classroom on September 14th, have your question, if any, ready. Which means you've been doing implicit homework. Implicit homework means anything I talk about here, go read about it in your books, look it up in Google, wherever you want to find it. That's what the implicit homework is. Eventually I'll quit saying that. I'll say it for the first few weeks. And they're paper exams, they're not online exams. I give you pieces of paper. So you know how to write, you need to know how to write. You need to know how to write, not tiny, because as you see, I have to wear reading glasses because I'm old. Don't write tiny. Right? If I can't read it, it's wrong. That's the definition of, one of the definitions is wrong. If I can't read it, it's wrong. Questions about any of that?
Do you have any more information on the exam, just like format or categories of the questions? I'm sorry?
The format is everything. You have multiple choice, you have true, false, you have essay, you have coding.
Okay.
That's why there's no point in asking me what the format of the exam is. It'll be, the format is everything.
Okay, thank you.
Right? Because the objective is not to take an exam and pass a test. The objective is to demonstrate you've acquired the knowledge. And that's the big difference between this and a lot of computer tests. And the test is designed such that you can't memorize and regurgitate. You have to understand. Right? Remember I keep telling you know why? That's what it means. Know what it means. You have to be able to problem solve. But there'll be some things that ingest and regurgitate work for, right? But you also have to be able to solve problems. Nothing terribly complex because the language isn't terribly complex. Right? The logic that you're doing in here isn't terribly complex. You get a lot of that in data structures. So if you continue on, you will get that eventually. I guarantee it. If not here, like if you take either one, actually, if you take a data structures class, the only two people to teach it are me and Glenn, I know that you'll have problem solving to do. Questions? All right, questions on the material from last week? Anything we talked about? Okay, the first 3 labs were trivial. I mean, literally trivial, right? So if you got a 0 on those first labs, you should consider dropping the course. Okay? Because I wrote the program essentially on the board last week. In fact, I know I wrote exactly one of the programs on the board. And the interpolation from int to character to whatever the other one was. Oh, just my name, just a plain print, and then the int and then the character, right? Very true. Okay, questions from last week. Anyone's name I didn't call on the roll? Okay, let's get started with why we're really here. Okay. Types. Let's talk about types of variables. Okay. The first one are integers. Int is a declaration, short is a declaration, and long is a declaration. Now, one of the bad things about C is that C was specified loosely. So what that means is the definition of an int is dependent upon the operating system, the compiler, and so forth that you're using, in strictly speaking. Now, in reality, right, the way it has shaken out is int is 32 bits, short is 16 bits, and long is 64 bits. Okay? That's just the size of those integers. So they contain integers. Integers are counting numbers. 0, 1, 2, 3, 4. You keep going until you've reached 16 bits, or 32 bits, or 16 bits worth, or 64 bits worth, actually. Because these are signed, it uses 1 bit to keep track of the sign, so it'll be 31, 15, and 63. And there are flavors of, you can put unsigned in front of you. Say unsigned int, so you get the whole 32 bits and so forth. But we're not going to go into that level. Just int, short, and long. And they are integers. 0, 1, 2, 3, 4, on up to 32 bits, 31 bits, and 0, minus 1, minus 2, minus 3, down to 31 bits. Because you have 1 bit that keeps track of the sign, whether it's positive or negative. Short, same thing, just less bits. Long, same thing, just more bits. A bit is an on-off representation. We're not going to go into, not tonight, we're not going to go into binary encoding and how that works. I don't know if we'll ever go into it, but certainly not tonight. Double precision, oh sorry, floating point. Floating point is when you have decimals, like 3.14, 15, 2, 8, something, whatever type, right? 3 dot and a decimal, right? 3.0 is still a floating point number, even though it happens to have an integer representation as well, but it can be a floating point number. Okay? So you have a float, which is contained in 32 bits, and a double, which is contained in 64 bits. Now the way that's actually maintained in the bit fields is a mantissa and an exponent. We won't go into the details of that. But suffice it to say, you can have floating point numbers that are decimal oriented. In other words, you can have fractions after the decimal. Those are the main types of numbers: integers and floating point numbers. Boolean, on and off. Strictly speaking, C does not have a Boolean. The way a Boolean is defined in C is 0 means false, anything else means true. That is the way the Boolean expression is defined in C. So, for example, if you write a program like this, okay, starting at that end of the second row with you. If I wrote this program, is your declaration. X is equal to 5, y is equal to 0. If x, printf, true, what will this program do? Will it print anything? Will it print true or not? You have to guess. Yes or no? You think it'll print true? Why not?
Because you're not defining what truth is.
This is a Boolean, it takes whatever is in here as a Boolean expression. What did I just say about Boolean expressions? The only thing that is false is if this is 0. Anything else means it is true. So is this going to print something? No? Is this 0? Is x equal to 0? So x is not equal to 0. So that means this expression will be true, and it'll print true. That's an important distinction. Almost every other language has an explicit Boolean that is set to true or set to false. Okay? C is not one of those languages. C works this way. So that means you can literally put anything inside the parentheses, and it will execute based upon if the thing inside the parentheses, whatever it may be, evaluates to 0, it is false. Anything else is true.
What if you put a method there that returns void? Because that's not null. Would that still be true?
You might very well get a syntax error. I have to think about it.
Okay.
You'll either get a syntax error or you will get false. Get treated as false. That's a good question, though. I'd have to try that. I'll try it in a little while. Okay. So, any questions about these types and Boolean? The Boolean thing is important. We're going to expand on that, on what you put inside the if in a moment. So you have to understand this first. Okay, Boolean means true or false. Right? The definition in C is that there's some expression. Right? There's some expression inside the if. Whatever the, and we're going to do some more complex expressions in a moment, right? But whatever the expression is, it is evaluated. If it evaluates to 0, it is false. Anything else is true.
So any non-zero value will always be considered.
This I'll rarely see. This I'll see. Go ahead.
So it's like just summarizing, any non-zero variable will be considered true when used as an argument for Boolean.
Any yes. Whatever the evaluation is, if it's non-zero, it'll be true. Let me tell you why what I just said matters. Because we have this common mistake that I told you about last week. If x is equal to 5, so let's suppose suppose I put x is equal to 3 in there. Now then, next person's from the second row. What is this actually doing?
It's assigning 3 to x.
That's correct. It is assigning 3 to x. If I really wanted to do the comparison, what would I have to change?
Double equals.
I have to put double equals there. That would be the comparison. Okay? Well, let's suppose I made a mistake, or this was my intent. It doesn't matter for our purposes. Because as he said, this will assign x is equal to 3. Now, if your purpose was to compare x, which is 5, to 3, you would expect this to be false. But because you put a single equal instead of a double equal, it assigns the value 3 to x, and that is the result of this expression, is 3. So therefore, because it's not 0, that expression will yield true. That's just the way C is.
So you can assign x to 5 and x to 3.
Oh yeah, you can, and then you can come down here, keep on going, x is equal to 13. It's a variable. So a variable means it can vary. It means you can change it.
So in other languages, when you do that,
Sorry, speak up a little bit.
in other languages, when you set a variable equal to a different number, it changes the state of that local variable, or changes that local variable to that number, for example?
It depends on the syntax of the language. In C, C++, C#, Java, it's all like this.
So if you were to say, like, under the line x equals 13, if you added, like, print f, and then you printed x,
Yep.
would it say 13 or 5?
if I said right here, like that, what do you think it would do?
Well, I say print 13.
That's correct, it would print 13.
Okay, cool.
Because x at this point of the execution is equal to 13. Questions?
Does the double equal sign compare them instead of
Yes.
assigning them?
The double equal sign is the comparison operator of equals. We're going to talk about conditional expressions maybe if we get that far. There's not a lot to say except you have equal equal, percent equal, which means not equal, less than or equal to, a few others, right, that you can look up. But if we don't get to it tonight, we'll get to it next week, right? Because that's where it is on the list.
You know how you said x equals 13?
Yep.
Like, what if you deleted that and you kept the print down? Then what would the x be, 5?
You mean if this was not here?
Yeah. And then what would it print out, 5? Like, percent d comma 5.
The way this program is written, what do you think it would print out?
What am I think 3.
You think?
3.
Why? Why do you think?
Because it's in the if statement. Like, it's not in there, but like, because it's true, that's why it's going to print 3.
Because x is assigned 3. You're exactly right. It would print out 3. Because I removed that. You guys noticing a pattern? When you ask questions, I ask you questions back to get the answer out of you. Not to be mean or anything like that. In fact, it takes longer. But I'm trying to get you to think. To think and express yourself. It's okay to think. It's okay to be wrong. God knows I'm wrong a lot. Ask my wife, right? One more time.
That prints true and then 3?
Yes. It would in fact print true and then 3, in fact right behind the letter true. To really clean this up a little bit, I would put \n in here, which we're going to talk about in a minute and when we get to escape sequences. But yes, it would print true and then 3.
Oh, you said true right behind letter 3. I thought that you meant like.
Sorry,
That's
true
not-
right before the number 3. See, did a lot of things right. You guys have heard the saying, if a tree falls in a forest and no one's there, does it make a sound? The answer is yes, there's still a vibration. If a man is alone in the forest and speaks, is he still wrong? The answer is yes, guaranteed every time, if you're married. If you're not married, you might make it. That's okay. Married men, we make a lot of jokes about our wives because we're the joke from their perspective. But anyway. Questions? Okay. That's tight. Formatting specifications. And by the way, if you have questions later after you've thought about it, you can come back. There's no problem. Formatting specifications. So where are we? Third from the end. What does percent %d do? Print out. What is that used for?
Printing
Right here.
yeah. Printing a number?
It prints a number, in fact, an integer. Yeah. Right? Percent I is the same thing, right? They rethought it as they got on down, said, okay, we need an integer. Okay. Next. What do you think? Percent F does?
Is it print character?
Not character.
It prints a float.
A floating point number?
Yeah.
Yes, that's what it does. It prints a floating point number. That being a lowercase l. Next, what do you think percent LF does?
A long float?
Which is a double.
Oh, okay.
But you're right, it comes from a long float, which they call a double, right? That's why you have to know what these things are, right? Next to him, percent C. Character. It prints a character. These things are going to matter when we get to scanf and scanf_s, right? I mean, they matter already for printf, but you've done printf, so you've had some experience with that, so you have this one.
Well, could you go from %d and %i again? What is it?
Integer. That's what they do. And there are variations on these. These format specifiers can become more complicated, right? You can put numbers and decimal points and things like that in front of them to specify exactly how you want it to look. For our purposes, we're not going to get deep into that, I don't think. It'll be just simple. Yes?
Is %d or %i considered standard? And in which case, is there like any reason to use the other in some cases?
I do not know of any preference between the two. They are synonyms. For our purposes, if they're synonyms, they do the same thing. It's up to you. But if I ask a question, what does %d do? You probably should know. If I ask a question, what does %i do? You should probably know. Or what it's used for.
When I was troubleshooting the integer assignment where we print the integers.
Sorry, one more time?
Where we like read integers.
When you read an integer?
Yeah.
Yeah, that'll be the scanf.
When you do that with a large enough number, it just turns -1 instead of like an actual integer. Is that like does %i and %d, do they have like a range that they can go?
No. It's probably you're not understanding of what you actually have to supply to scanf, and which is why we have to do that how a computer works first, so that you'll understand the context of what I tell you the parameters following the format string have to be. But hopefully we're going to get there. In fact, we have to get there because you have something due Sunday that requires that. Questions on that?
So, what's the actual difference between long and double, since previously said that they're the same, but double has a decimal, long doesn't?
You mean this one?
Yeah.
This is, so LF is actually a double, which means it's a larger precision number. It can be a bigger number, it can be a larger number of decimal places, whatever's combined, right? Than simply a float. We've discovered in life, in physics and everything else, that 32 bits is not enough to contain the things we run into in the world. For instance, this is binary, we'll give you a quick binary list. What is 2 to the 10th about equal to? It's a very big number, that's right. It's roughly equal to 1 million, a little bit more. That means 2 times 2 times 2 times 2, 10 times, right? Therefore, 2 to the 20th is about how much? 1 million times 1 million. 2 to the 30th, what is that going to be? You guys can figure it out at the lab, what those numbers are. So, 2 to the 8th, 2 to the 8th is 256. Sorry, 2 to the 10th is about 1,000. 2 to the 20th is about 2 to the 30th is about 1 billion. So as you can see, 2 to the 30th is 1 billion. You add 2 more bits. 2 to the second is 4. That's 4 billion, right? What that means is a float is not large enough to contain our national yearly deficit. Right? For example, that's why we have to have doubles. In fact, in most cases, almost no one uses floats anymore in programming. They simply use a double because it takes up twice as much space, but so what? We used to care a lot, we don't care anymore.
Can a long contain it or no?
Yeah, a long is the same thing in terms of an integer, right? A long can contain 1 billion, well, 4 billion. Well, with the sign bit, it'll contain 2 billion. Negative 2 billion, a little bit more. The positive 2 billion, a little bit more.
So basically the double is just the double of the long, right?
No, a double is a floating point number that's twice as big as a float. A long is an integer number that's twice as big as an int.
So what's the similarities between a double and a long?
No. This is an integer. This is a floating point number. Okay? Which means it can have decimal places. So you can, and it can contain larger numbers because of the way mantissa and exponent work. Which they should have taught you in a math class somewhere, but I'm pretty sure they didn't. But you get to go look it up now. Any other questions? Three things. We haven't talked about scanf yet, so a lot of your questions about scanf. We're going to talk about scanf tonight, okay? But if you want to get ahead, which is a good thing to do, you can always study scanf and what it means. Now, some of you may not have the background, which is why we're going to talk about how computers work and references and pointers, which will give you the right context, right? But I guarantee you never saw an example doing what some of the code you tried to get me to fix for you is doing, right? So computers are exact. Computers do exactly what you tell them to do, right? Not what you mean for them to do, exactly what your code says to do. That's what a computer does, okay? It is exact, very exact. So you'll see some interesting things that happen when you do the wrong thing because the computer did exactly what you said to do. Unfortunately, the C compiler does not do look-ahead error correction as well as many other compilers. Because the C compiler was originally written to do exactly what you said because performance matters a lot, storage matters a lot, space matters a lot. Okay? You used to have limits that said 640 kilobytes was the maximum you could have on the computer, right? Which is a joke now. You could never run anything with that, simply because the operating system wouldn't run in that, right? So they fixed all those problems by technology advancing. You know, once upon a time we could fly airplanes, but we couldn't fly to the moon. We were going to try to fly to the moon Monday. That didn't work, so we're going to try again Friday. Hopefully it'll work. But I predicted there would be some problem Monday because I don't think they've sufficiently tested things. But that's just me as an engineer knowing what happens. But I used to run linear accelerators. So I know, and it's tough to get things right. I mean, this is hard stuff that they're doing. It's very hard. So I don't think they're taking the right approach necessarily. Just like Boeing with Starliner. They didn't test it right. Okay, any questions on anything I've gone over so far? Here's the other thing to remember. It is perfectly fine to talk to one another, to get answers, to get clues and help like that. But as one student has discovered, more than likely, I'm going to give you the better answer than your neighbor. Which doesn't mean you shouldn't consult your neighbor and work together and not turn in the same work, just discuss things and then go off and do your own work, right? That's okay, because sometimes you just need what we call in computers, a second pair of eyes. Because you're staring right at it, somebody else walks up and say, oh, just that, right? That's just how human brains work, right? You just stare, and you missed a percent sign or you missed something, right? That's obvious to somebody who walks up and just glances at it, right? That's just human nature. It happens to me. Well, not very often anyway, because I learned to make myself the second pair of eyes. I go off and do something else, and then I come back and look at it. But sometimes that doesn't work either. Sometimes I have to say to my neighbor, June, look at this. What am I doing wrong? She says, you're an idiot. Look at, she doesn't actually say that, but that's what I say to myself. I'm an idiot, because she finds the problem easily. It's okay to talk to people, right? But more than likely, if you have a question, I'm going to probably give you the better answer. But certainly feel free to work together. I don't mind. Just don't accept what other students in the class say as gospel, because they may or may not know. There will be some students who absolutely know, and they don't. Right? I know that simply from teaching computer science and working in computer science for a long time. All right. Any questions about types, formatting specifiers, anything else we've gone over tonight? Okay, integer arithmetic. Let's talk about integer arithmetic real quick. Suppose you have nx is equal to 9, and y is equal to 6. Where did we stop? In this case, what is x divided by y, i.e. 9 divided by 6, going to equal?
32. So we have 2, 1.
No, it's got to be an integer. 1, 2, 3, 4, 5, 6, 7, an integer. What is 9 divided by 6? How many times will 6 go into 9?
Once.
Once. Okay, next. X divided by z, i.e. 9 divided by 4. 2. 2. Let's suppose I change this to be, let's suppose I add another variable. And a is equal to x divided by a. In other words, 9 divided by 2.
4. 4.
4. Okay. It is truncation. Even if it ends up being more than, closer, even if it's not rounding, it is truncation. Okay. The math expression is floor. It's the math. It says whatever it is, take it to the lowest number below it. So truncation. That's what integer arithmetic, how it works in the C language. Okay? It is truncation. It is not rounding. That's just something you should know. Escape sequences. Hopefully that'll be quick. Escape sequences. Escape sequences start with the backslash. Not the forward slash, the backslash. Which on a keyboard, most keyboards, is an unshifted bar. In other words, on most keyboards, it's the key right above the enter key. On most keyboards, right? Backslash. So escape sequences, let's just talk about a few. In other words, they cause special characters to be output. Backslash n, the n stands for new line, right? Which is actually a line feed. Means, well, think about, once upon a time, people did everything on typewriters, okay? So when they were starting to invent computers and printers, they had a typewriter mindset. And most of you probably never used a typewriter. But remember, it had a sheet of paper on a roll, okay? So that's what line feed comes from. It moves to the next line, okay? Backslash R is carriage return. Now the carriage was this thing that held a sheet of paper and it moved back and forth. As you typed, it slowly moved to the left as you typed characters, so the characters would go to the right place. Okay? That's what the carriage is. Okay? When they say carriage return, it means it moves it all the way to the right. In other words, it puts you starting at the beginning of the line. Now different operating systems, essentially there's two. There's Unix derived operating systems, which is everything else except for Windows. Okay? They treat these things slightly differently. Windows requires both characters, which strictly speaking is more correct. It says a line feed, which just moves up, and then a return, which moves you back to the beginning of the line. But most Unix-based computers, which will be Apple, Android, so all those things, any flavor of Apple, any flavor of Unix or Linux, and any flavor of Android does \n is both line feed and carriage return. That's why it's the \n actually refers to new line. Right? That's what the n stands for, new line. It just takes you to the beginning of the next line. In most cases. And if you in fact use \n, that's exactly what it'll do. So you put these in a character string, and they'll do whatever you say. \n is new line, which is typically all you ever need to get back to it. \r, that's just in case you see it somewhere, you'll know what it means. \t is the tab character. Okay? And it moves you over to the next tab position, which could be anywhere from 1 to 8 characters, depending upon how your tab setting is. But it moves you to the next tab position. It doesn't add 8 characters to the next tab position. Mostly you don't have to worry about this. The big one that you should care about is this one, \n. That'll give you a new line, which is frequently what you actually want. You discovered if you did printf, it did multiple printfs, it ran things together, right? The \n is how you start a new line. And look it up. Implicit homework. Go look up escape sequences. Comments. We talked about comments last week. Everybody sit there and enter these numbers into a calculator to find out what the numbers actually are. Go home and do it. It'll be useful for you. Especially when you get to data structures. I'd say this again. Sometimes the instructor won't say it and you'll be lost. Right? Because it helps to understand what these numbers are about. This is the tilde here means about. Comments. What does this comment do? What does this double slash do? That's a forward. This is a forward slash. What does the double forward slash do? Just guess if you don't know. I don't know is never an acceptable answer here. You always have to guess if you don't know. It's a comment that says everything from here to the end of the line is a comment. The compiler will not care. Next time you got to guess. Okay. I don't know doesn't work. You've got to be in here and think. Okay. You've got to be in here and think. Because when you go out there in the real world, you got to think. No matter what piece of the IT profession you use, you've got to think and try and make an effort. Yes, sir.
You have to do double slash space and then start writing type
Nope.
of comment? Or?
Nope. Double slash, anything following it, to the end of the line is a comment. Okay, so int x is equal to 7 will be valid code, int y is equal to 9 will be valid code. So that's one form of commenting. Next, okay, here's another form of commenting. Will the integer z actually get declared? No. Why not? Right. The slash asterisk says everything after it is a comment until asterisk slash. Okay? That's the form of comment. Those are the two forms of commenting. My personal belief when I write code is that if it's worth commenting, it's worth using this. I almost never use that. Because if it's worth commenting, it's worth putting it in a block and making it stand out. That's my general programming advice to you.
Just out of curiosity, do you know how it works in Python? Like, I've never tried
No idea.
to think of things.
I don't know about Python. Python is one of those languages I use occasionally when I need to be sloppy about something. I almost never use it otherwise. I've never found Python to be a useful language. I found other things to be far more useful. Although a lot of people like Python, I fix a lot of Python problems by saying, well, here you did this and it's sloppy. If you do this, the problem goes away. Because Python allows it. JavaScript allows it. Unfortunately. Scripting languages in general allow it, which is, we're going to have aircraft carriers run into shoals at some point because of it. We just haven't yet. Okay. Comments. Those are the two ways to comment. Double slash and slash asterisk up to the asterisk slash. Okay. Questions? Yep. Assignments. You should be able to get through assignments pretty quickly. Who's next? What does the first line do? Declares x and then assigns it to a 3 to it. Next. What does this line do?
Just puts insert y and with the sign into.
Okay, so at this point, what is the value of y?
Null, 0.
Nope, it is done. In a lot of other languages, like C# and Java, it is 0. In C, it is undefined. Said betterly, it is unknown. It is whatever happened to be laying in memory where the variable y is stored. When we get to how computers work, we come to understand that. So what's the next line do? It sets y to a value of 5. Okay? That's the easy assignment statement, right? Okay. Now, third row. First person in the third row. What is x plus plus? No, you're going to add to x. What can you add to x? Just another number, right? What numbers are going to add to x? This is the same thing as x is equal to x plus 1. X plus plus. It just increments x. Okay, next. What do you think plus plus x does?
It does the same thing.
It is the same thing. Next. X plus equal 1. Same thing. Next. X plus equal 2.
Oh.
We'll add 2. This is what we call syntactic sugar, right? You can easily write these things, right? This is just, it gives you a little shorthanded way of doing it. Now then, there are some wrinkles with these guys. Because remember, they have erased, here it is, right? Any expression always results in a value, okay? So the difference between the plus plus being after the x and plus plus being before the x is this. It's when it's evaluated and then added to, or when it's added to and then evaluated. So for example, and remember, everything I say has what associated with it? Implicit homework. In other words, I'm just giving you the quick definition and everything accurate. To completely understand it, you have to go work at home. Okay. Okay, where are we in the line? Okay. That piece of code, is it going to print something or not?
It'll print true.
Why?
Because 1 plus x, which has the value of 3, is the same as y, which is 4.
Okay. If I change it, next person. If I change it to that, will it print? You want it? You have a 50-50 chance. Worst case is, hopefully you have a 100% chance because you understood what I said earlier.
I think it's true.
So it's going to print true.
Yeah.
Why?
Because x plus
Okay. It will not. The reason is because when the plus plus follows the x, it says return the value of x before incrementing. So the value of x is 3. 3 equal to y will be false. So it will not print f true. But if you later say that's going to print 4 in both cases. It's a matter of plus plus in front says do the addition do the increment first, then evaluate for whatever purpose. Plus plus after says evaluate for whatever purpose, and then increment. Sir?
Would it be advantageous to use that notation of x plus plus in a decision statement like that?
Okay.
That very well issues can pop up.
That's an excellent question, because here's my advice. Never do that. Never do that. Right? There are a few instances, very few instances, where it is helpful. In most instances, do it on its own line. Okay? The reason is because, as we have seen, this is a little more complicated to understand. Just do the obvious thing. Make your programming simple and obvious. Okay? That's my recommendation. But as far as C, this is perfectly valid C syntax. It has ramifications about where you put the plus plus. Okay? My recommendation is do everything you can to avoid putting this in an expression. Do it separately. Question? Sir?
So if you put the 2 plus signs before x, so is it going to be saying x plus an integer is being compared to y?
No, if you put the two plus signs before it, it says evaluate x, which means it's going to use it in this evaluation. X is equal to y, which will be false. But then it'll still increment x, which is why it'll still print 4 here. Okay? That's why try not to do this, because it's confusing, right? And you don't care about you, you probably knew what you meant, but it's the next guy when you've stepped in front of the bus on the way home. It's the next poor guy that has to figure out your code, right? Obvious code. But I have to tell you how this operator works, because this is a C class. And when you come out of here, somebody hands you a C program in an interview and says, what does that do? Now I've taught you. And if they ask you this kind of silliness, you probably don't want to work there, because they have the wrong attitude about interviews, right? Because this is tricky. That's a trick question, what we call it. It doesn't define anything about your problem solving ability. It says, can you figure out this trick, right? I do not ask trick questions. I have gotten up and walked out of interviews that I was interviewing for. I said, thank you. You're asking a lot of trick questions, and I probably know the answer to every one of them. But because this is your interviewing technique, this is not a place I'd want to work. And I walk out the door. I've done it more than once. And not every time. Almost every time, I get a call back from a higher manager apologizing and saying, please, please, please come back in. And depending upon how he apologizes, if he apologizes with intelligence and merit for the interview process, I'll come back in and give him a chance, right? Because they need me a lot more than I need them, always. And now that depends on who you are and where you are on the spectrum, right? In my case, they need me more than I need them every time. Right? So you should try to get to the point where you have that power, right? Where you're very good. But you have to pay your dues to get there, right? I paid dues, right? I've worked 70, 80-hour weeks. I worked all night some nights, right? Solving problems with the program. The email program, that was a couple of all-nighters, not in a row, but a couple of all-nighters, right? And it was trivial. From my perspective now, it was trivial. Back then, it was groundbreaking to the world, right? But from my perspective now, I could write that in a couple hours. Right? But 40-some years ago, it was really new stuff. Yeah, 43 years ago. Okay, so, anyway, it's tricky. Don't be tricky. Be clear. Write it out separately. Right? Okay, so this is increment. This is shorthand plus equal. You can do x times equal 3. That'll multiply whatever x is by 3 and assign it to x, right? All sorts of tricky syntax. I do this one sometimes, right? Not often, but I like to write really, really, really clear code. Because I'm going to look at it in a week, and I don't remember what I wrote or why I wrote it. So you can do that with all the operators, slash, equal, what have you. Okay. One of the operators I left off that I forgot, I apologize. Oh, I didn't even talk about the operators. Let's talk about, oh. Okay, so that's assignment and increment. Now we're going to talk about numeric operators. What I forgot first. Numeric operators. These are going to be pretty simple and obvious to you. Who's next in line? What's addition?
Plus.
Next, what is subtraction?
Negative.
What is multiplication? Star, asterisk, what do you call it? What is division? Slash, forward slash. Who's next? What is, hello? What is modulus? We've done addition, subtraction.
Oh, that adds two values together.
And that's what addition does. What is what's the symbol for modulus? Or what does modulus do? Pay attention to the class. There's a percent sign. Next person. What does modulus do?
It prints like the integer that you have defined.
Okay, so suppose I say int x is equal to 7, int y is equal to 3, int z is equal to x modulus y. What does z become?
4.
Nope, that's subtraction. But it's related to subtraction. Well, it's related to division, actually.
1.
It is 1. Why?
Remainder.
Remainder. That's exactly what it is. It is integer remainder. Very good. So it is 7 divided by 3, whatever's left over, the remainder. That's what modulus gives you. Okay? When you get to data structures, we're going to use modulus a lot for purposes that will become clear in data structures, but it's easy to use in some ways for demonstrating and doing certain things. Okay? So this is something your math class should have taught you, but obviously didn't. I'm sorry for our education system. I apologize again, the American education system. Some people are trying to make it better. Not fast enough to, well, some of you have had Common Core math, so that's helpful. Okay, those are the arithmetic operators. We'll get to conditionals later, I hope. Any questions about numeric, otherwise known as arithmetic operators? Addition, subtraction, multiplication, division, and modulus. And there are others. These are the main ones. There's unary things that we'll talk about them later. Okay.
Yeah, I have a question about the modulus. So the remainder is like after the decimal?
Modulus only works on integers.
Okay.
So you don't have a decimal. In other words, how many times does 3 go into 7? What is left? So 3 goes into 7. 7 divided by 3 is equal to 2, with the remainder of 1.
It's always the lower number that goes into the
No, it's the order. It could be 3 divided by 7. For integers, what is 3 divided by 7 equal to? Talked about that earlier. It is truncation, it is not rounding. So 3 divided by 7 is going to be some fraction between 0 and 1. Since it's a fraction between 0 and 1, therefore what does it become? It's truncation. What does it become? Say again?
truncation.
Yes, if you truncate 3 divided by 7, what's the value? Oh, it is 0. 3 divided by 7 is going to be 0.4 something, something, something. You truncate it, right? Because it's not 1, you don't round up. And this is because it's the last thing you wouldn't round up anyway. Truncation is equal to 0. There are no stupid questions.
Does modulus, is it only defined if we actually define integers instead of in the float?
It is only relevant for integer values. If you're doing floats, you cannot take a modulus of a float because it's meaningless, because the float arithmetic can result in a decimal point number, a floating point number. So modulus doesn't even make sense. It is only applicable to integers.
But if we didn't write integer instead equals x modulus y, would it not appear? If we divided 7 by 3, would it be truncated?
So in other words, suppose you did this. What would it do? I do not know. But you can write a little program and find out. Now I'm curious. Because in a good compiler, you're going to get a compiler error. In C#, I guarantee this will give you a compiler error, right? I've never done it in C#, but I bet money it will give you a compiler error. Because C does not apply all of those constraints, it might, I don't know what it would do, right? It might result in Z being 1. Or it might treat modulus for floats as a pure division. Well, but as a remainder, how would it do that? It might, I don't know. Write a program and find out. I'll be interested in the answer. But conceptually, it does not make sense because it is the integer remainder. That's what modulus is defined to be. Okay. Any other questions before we start talking about how computers actually work? Okay. How do computers actually work? So, the thing to understand first is that I am going to give you the shortest version of this that I possibly can, and a lot of it will not be exactly correct, but it'll be sufficient for you to understand the concepts. Okay? That's the first thing to understand. With that caveat given, let's talk about how computers work. Let me make sure this is what it is. Stack and heap, it is. So a stack is like this. A stack is last in, first out. It's just like a stack of books. Putting a stack of books together, or that game called Jingo or Zingo, or where you pull out sticks, you run out to make it fall down. Right. Jingo. Okay. The simplest thing, right, is take it off the top. Right. So think about a stack of books. You put something on. The last thing you put on, last in, is the first thing you take out. That's how a stack works. Okay. So when you write a program, the simple variables, the value type variables, go on the stack. Okay. Now the heap is just a pile of memory that things that are not simple variables go on to. Okay. Now some of your questions, some of the things you guys have been working on, hopefully in a few moments there's going to be a great dawning of light on you. Okay. So if I say int, float, double, long, whatever in the program, as the program is executing, they go on the stack. So let's suppose my program says float x, float y, and float z. So on the stack, x comes first, y came next, z came next. Let's suppose I declare an integer a is equal to 13. A would go next. Okay? Because they're simple variables. They are value type variables. They are not complex, they are of fixed size. Small fixed size when you get right down to it. So when they are declared in your program, they go on the stack. Now the thing we haven't talked about is something called arrays. So let's suppose I declare an array. Int b with 13 entries. Okay? That is an array of integers. It happens to have 13 integers. The indexes of those integers will be 0 to 12. Array indexes always start at 0. Okay? So I've declared an array. Now how does that look in memory? The way that that actually looks in memory is you have b, but treat it as a pointer, and that's going to become significant in a minute. And this pointer will actually contain the memory address where that array actually is. Because the data for the array is not in the stack. Simply a reference to the data is in the stack. And then, let's make this simpler. Let's suppose I declared an array with 5 instances. I'll make my drawing simpler. So this is where that memory, or that data actually lives, is in the heap. What goes on the stack is simply a pointer to this data. Okay? Now all this I have to do in preference to explaining to you how scanf works. Right? I could tell you how it works by rote, but then you wouldn't understand why you're doing it. I always teach the why, that's more important. Okay? So, when you declare anything that is not a simple variable, simple variables are the integers and floats. Everything else is not a simple variable. Okay. The actual memory lives in the heap, and the pointer or reference to that memory is on the stack. Now there's going to be cases later on when we get to structures where that isn't completely true. But for our purposes right now, treat it like this. When we get to a more complex situation, we'll correct this. Well, actually, we'll not correct it. We will expand upon this. But for now, when you declare something that is not a simple variable, right? If I say char C, where were we in the line? In the question line. Who had the next question? Who answered the last question? Somebody along the third row. Okay, yeah, thank you. Where does the character C's memory get allocated? Remember, it's a single character. It's not even 32 bits, it's like 8 bits. Or maybe 16, depending on if you use Unicode. So you have a 50% chance. It's either going to be on the stack or the heap. No. Why would it be a heap? It's a simple type. C goes right here. Because C is simple. It can, you know, fit inside of a word. Fit inside of the width of the stack. Okay? So let's suppose your stack, you're on a 32-bit machine. If you use a long, it just takes 2 stack entries. Because it's still simple. But if you have anything like an array, or suppose you say, so first person in the 4th row. Suppose you have this. Char S, and I apologize for my handwriting, right? It's right up there with my art abilities, right? My handwriting abilities. If I declare a character array named S that has 20 entries, what goes where?
The S goes in the stack, and then it serves as a reference for the array rather than just heap.
Like that. That's exactly how it goes. Okay? Sure.
Why did you stop at 19?
Because I started index 0. If you count 0 to 19 on your fingers, you'll get 20. Because all arrays start at 0. Index 0.
Can we not start at 1?
Nope. Not in C. Not in most languages. Actually, C# and what have you are implementing something called ranges, which are they're putting a lot of stuff into C# they shouldn't be putting in there. It's syntactic, sure, because they made it open source. People are putting in their favorite features. That is both the detriment of proprietary things and the strength of proprietary things. The strength of proprietary things is that you get more input, creating a better product. The detriment is all of the changes people put in are not necessarily better. They can guide you to do bad things. Right? And bad things means your program runs poorly. That's why and understanding matters, so that you don't write programs that run poorly. In apartments.com, we care very much how fast the search page loads. Because we have statistics, that's what I'm doing right now, is putting in statistics gathering thing using Google Analytics, right? We gather statistics about how fast page loads, and we also gather statistics about abandonment. We discover that the longer it takes the initial search page to load, the higher rate of abandonment we have. Abandonment means people going to some other website, right? And we're not talking about 10 or 20 seconds. We're talking about 4 or 5 seconds. It's shocking to me that people would give up that quickly. But you guys have grown up in a connected network, in a connected world. Your brains are wired differently than my brain, right? We didn't have these. I had a calculator when I first got to college, and I was cool because we first started using slide rules. And I was a whiz using slide rules, log slide rules, and man, I was good at it. And then calculators came along, right? But it benefited me being able to use that slide rule because I understood how everything underneath worked. Useful. You guys have grown up in a different world, right? Your brains are wired differently, and I think, for the most part, better. But it also means some underlying things you have more difficulty understanding. You should see my daughters. They're halfway between you and me. And I can see it, right? When my daughter took over technical support from my mother, I was thrilled because I didn't have to do it anymore. Okay, Jackie's got it. Knock yourself out. Mom, you got a question? Call her. It's great. Right? The other two daughters are pretty good at it too. But my wife talks to the daughters simply because they have more patience than I do. And my wife wants to stay married, so she thinks that helps. She's probably right. From her perspective, because I would drive her crazy, it wouldn't be the other way around. All right, So this is how a computer actually works. Okay? So when you declare an array, the array is actually allocated over here. Okay? When you declare something, it has a location in memory, a number, an address. It has a memory address. So when we talk about pointers, that's all a pointer is a memory address. Another name for a pointer is a reference. Okay? So let's talk about what this means in terms of actually accessing memory. So, I'll get rid of this. Okay, so let's take these variables here. Let's say y is equal to 7. Okay? The compiler knows where on the stack y went, because he knows the order in which things are allocated on the stack. So he can assign 7 to y and just stick the value 7 in here. You can just put the value 7 in there. But if you say b sub 3 is equal to 13, okay? How does the compiler know how to get to that? The compiler first goes and gets the address stored in here, right? So the address stored in there is actually ampersand b, a reference to b. Sorry, I can't draw ampersands very well. I know they're kind of like 8s, but not exactly. Sometimes I practice it, and I can do it okay, but I can't, so I just draw this. This is an ampersand in my writing abilities, which are 4. Okay? So it gets a reference to b, which gets the memory address. We said this was S, this was B up here. Right? So it gets the memory address of b, then it adds +3 to it, and then it goes to that memory address and sticks 13 into it. Okay? That is how the computer actually works.
Logically speaking, is b sub 3, is that denoting the third box or box number 3? Is you put it in box number 3?
It's actually denoting the 4th box, because arrays start at 0. So,
Yeah. So
first,
it's not
second,
going in
third,
box
4th.
2. It's not going in box 2, it'll denote the 4th box, which is titled.
Right, because suppose, because it has to, because suppose I said b sub 0 is equal to 7. So you've got to give a reference to b, add 0 to it, and then you assign 7. Right? Now, if you do it as a literal, the compiler will typically optimize this away, but this is really what it's doing. Okay? So it gives the reference to b, adds 0 to it, so it's still right at the very front, and puts 7 into it. Okay? That's what pointers and reference means. When you get a reference to something, it says, I'm getting the actual memory address of it. Okay? I'm afraid to ask if everybody is with me so far, because I know some of you are not. Some of you are, some of you are not. That's okay. This is a hard concept the first time you're exposed to it. It is difficult, right? Which means you have to do this implicit homework and find some reading about it. Okay. Okay. So let's take, that's how computers work, because it is in the broad sense. Okay. It's actually a bit more complicated than this, we go into that in data structures. Data structures, I spend a lot more time about how things work. But not now. You just need to understand this so that I can get to scanf. Scanf underscore s. All right. So, we've got all this. This is how scanf is defined. It has at least two parameters. Excuse me. It has at least one parameter. Okay. No, it has at least two parameters. But it can have all the way to n parameters, whatever n is. Okay. Now the first parameter is a formatted input string. The placeholders, otherwise known as the formatting specifications, are exactly the same as printf for output. You have %d says an integer, %f says a floating point number, %c says a character, %s says a string, right? We'll talk about that in a minute. Okay. But this is what the first thing is. So I'm giving you exactly what it means, and then we're going to explain by example how this actually works. Ellipses means and so forth in the same fashion. Okay? Now we'll get to what this actually means and how it actually works, and hopefully you're going to see the great dawning in many eyes. Okay, so let's take the formatted input string. And let's assume for the moment this is what I've declared these variables, so we'll use those. Okay. Formatted input string. So it's a string, so it has double quotes. Where did I get to in the questions? Back of the fourth row? No. Second person back of the fourth row. How do I specify a character? What kind of quotes do I use?
Single quote?
Single quotes, that's right. Because many of you said char C is equal to double quote A, double quote, and the compiler gave you an error, I hope. And it said that you can't do that. It wouldn't compile. But when you changed it to single quotes, it compiled just fine. Single quotes are for characters. Double quotes are for strings. Now strings are loosely defined at the moment. We'll define them more precisely eventually. Maybe tonight, maybe next week. Yeah. But The first parameter is a formatted input string. Okay? So, it's actually not that complicated. So let's just take an example. Let's say you said %D, %F. Percents are poorly written. %D, %F in your input string. What that says is that scanf is expecting to scan from the input, standard input, which is the keyboard, right, for your purposes, an integer and a floating point value. Okay? And it's going to do it with those things delineated or separated by either spaces or separate lines. So how do you tell it for P2, which is a reference to the first destination, right? First destination says I'm getting an integer. How do you tell it, get it, and get it where to put it after it reads it in? Because scanf is for input, right? The way you do it, you have to give it a reference to where you want to put the value. Reference, reference, reference. Next person. What is the character that means a reference? What is the character that means a reference? I know I erased them from what I had earlier. Next person. It's an and. It's an ampersand. Ampersand. Okay? So that's what you have to give it. You have to give. So this is the kind of things given the first parameter. In the second parameter, we're going to give it a reference. So we're going to give it a reference to A. Let's say we want to stick that integer in A. Now then we're going to get a floating point number, so let's suppose we're going to stick it in F. Or X rather, sorry. X. That's what you would give it. So how would this piece of syntax actually look when all done together? When all done together, it would look like this. Hopefully the light bulbs are going off. You guys talking back there, there's a good chance I know more than what you're telling each other. Very good chance. Right. At least my employers pay me enough to make me believe there's a very good chance. I don't mean IBC, I mean the real world employer. Okay. Here's what you are missing in most of your programs, the ampersand. Right? You just put the variable there. You did not put the ampersand there. So in other words, remember when I said the computer does exactly what you tell it to do? So what happened when you ran that, what the computer is expecting for this parameter is a memory address. But when you just gave it A had some value like 7 or something, right? And it treated that as the memory address. So when it read it in, it stuck it into memory address 7, which is almost certainly not where A actually is. Okay? That's the mistake you made in most of your programs. And I knew that, but I wanted you to hear it this way. I could tell you put an ampersand in front and start working, but you wouldn't know why. Some of you still won't know why, some of you will. And the ones that will know why and care why, you're the ones I'm really teaching this class for. I'll just be honest with you. Right? So that's why A without the ampersand didn't work. Because what it's really expecting is a memory address to put the value into. And you gave it a memory address is just a number. So when you put A there without the ampersand, you gave it a number, which means you just stomped on some piece of memory. Okay? That's what really happened. So the person who said it works fine for short numbers, but doesn't work, or for short strings, it doesn't work fine for long strings, because you were stomping on some piece of memory, and then that piece of memory itself got stomped on. Because the computer does what you tell it to do, and exactly what you tell it to do. Even if what you tell it to do is wrong, it still does it. Okay? So that's how scanf works. Make sense? I hope. Hopefully it will make sense when you go home and start doing little programs to find out. So the way to do this, right, rather than write the big program, that's why you have those small labs which say, just take an integer, just input an integer. So you can practice doing that, right? And make sure you're doing it right. Then you expand it to bigger programs where you're doing more things, right? That's why that's the best way to learn it. Learn the simple things, and then you put the simple things together to make the more complex things. Do the simple things, test them individually, and then when you put them all together, you still have to test the more complex things. But you have to test it. I had people that turned in assignments and never tested them, because if they had tested them, they wouldn't have even compiled. Yes, sir?
So right now, is it saying that A is just a letter and there's no value to it?
Well, no, right there I declared A is equal to 13. So A happens to have 13. Remember I said we're using this set of variables? So A happens to have 13 in it. So if I did it without the ampersand, right, it would just go to memory address 13 and stick whatever input you put as a number there, wherever address 13 is. But then when you looked at A later, it wouldn't have 13. Because you didn't give it a reference to A. You just gave it a number. This is why I had to explain to you how computers work. They work by references to memory. Right? And that's what is stored everywhere.
So it's basically saying the stack isn't there, so it's just going straight to the mean.
No, it's using the stack. Well, for these purposes, it doesn't even know where it is in the stack. Because remember, scanf is some library. And scanf says, tell me what to do in the first parameter, take an integer, then take a floating point number, and says, and then evaluate them, turn them into binary numbers, and put them at the addresses you give me. And that's all you're doing is telling it what address to put it at.
Theoretically, where would address 13 be? Like in the stack, or is it not a thing at all?
Who knows? It's somewhere in the computer, right? It's almost certainly not in your program. Well, that's not actually how they work. You have an isolated memory space.
Right.
But the one thing that is almost guaranteed, it will not be the actual location of A.
Okay.
That's all that really matters.
Is the stack numbered at all, or does it have?
Oh yeah, it's like an array. I mean, it is an array, right? We just draw it in that way because of how stacks work, you know. Last in, first out. We just draw it that way, but it's actually an array when you get right down to how the operating system treats it. But it uses the indexes because the compiler knows when you declare a variable what index it is at. It actually knows the index it's at from the last execution environment, which is more complex than we're going to get into in this class. But in data structures, I'll tell you all about. Okay. But for your purposes, the compiler knows where X is declared, what exactly where it's declared, right? Which is why when you get a reference to A, it goes to the actual memory address of the stack and adds 3 to get to A, And that's the memory address it passes to scanf when you use this reference operator in front of the variable name. Question over here?
No.
Okay.
So to be clear, when you're not including ampersand, it's just assigning it to random to the numeric value for that character A, like in the system. But when you include the ampersand, you're referencing.
For our purposes, you're sticking it randomly somewhere that is wrong. That's all that matters. It's wrong. You have to do the reference to A to give it the proper destination. Okay. Question? Questions? So hopefully, we'll go home, write some programs and test it. See what happens. That's how you do this, right? That's how you learn to code. By coding and making mistakes, seeing what happens, and figuring it out. And then getting references from your book, from Google, from wherever, Bing, whatever, to find out why you did isn't working and how to make it work. Right? I've told you the key. You have to say reference to the location you're going to. So hopefully you'll understand why and not just do it by rote. But if you do it by rote, that'll work too, for a while. Okay. Questions so far? Okay, here's the next curveball to further confuse things. Hopefully not confused, but give you some of the inputs you're going to need. Let us talk about strings. There's no such thing as a string in C, except by convention. Because all the variable types are what we put up here. Int, short, char, float, all those things we put up here, right? What a string is defined by convention to be is a character array of whatever value you give it, right? With null termination. Now, ASCII is the character set we all use. I'll let you go look up ASCII at home. Right? Those of you who do have a chance in computers because you have a curiosity to you that will serve you well. Those of you who don't probably won't work out in computers. Right? Every time I say go look up something, if you go home and choose not to, you're not doing yourselves any favor, and it's saying something about whether you should be working in computers or not.
How do you spell them?
ASCII. ASCII. Okay? Go look it up. It's a character set. And what it's going to tell you is that when you see the numbers 0, 1, 2, 3, those are not the actual numbers used for print format. Okay? There's a coding number. This is what this is a character encoding. Right? So that's what it means. It means character encoding to make something visible. And some things are not visible. So when it reads in, so when you type in, for instance, on the keyboard, A, B, C, A has a code, and I don't remember what the code is. Let's say it is 31. Let's say B is 32, and C is 33. That is what actually comes in. And actually, I think 31, 32, and 33 are actually the character codes for the printable characters 1, 2, 3. but they do, obviously 31 is not the value for 1. It is simply a representation of 1. So when scanf reads it in, it's going to see 31, 32, 33, and it's going to translate that to a value of 123 when it puts it into an integer variable. Okay? That's how scanf works. It is doing the interpretation for you, the formatting, if you will. Remember we said format specifiers? It is doing the formatting of your input into a decimal representation in your variable. Okay, so back to a string. So a string is a set of characters with null termination. What null termination means is it actually has the value 0, not 31, 32, the value 0 in it. Okay? So if you'll recall, we talked about escape sequences. \n, \r, \t for different characters. \0 is how you get the null special character that terminates a string. Okay. So that is how, by convention, a string is defined. It is a set of characters with a termination of a null, which is \0, which means the character has the numeric value of 0. That's how it knows where the string ends, by convention. Okay? The C language doesn't know anything about that. The libraries do. Scanf, printf, remember we said we use libraries? They're libraries that know those conventions, but that's all they are. They're not part of the C language. They are conventions. But they are the convention everybody uses, so it all works out. As long as you understand the convention and what it must mean. Okay, so let's suppose you want to read in a string, which some of your later assignments are going to want you to do. So, does anybody know what the format specifier for a string is?
Would it be scanf _s?
The format specifier is %s. Okay? So, let's suppose you declare an array called S that has 20 entries in it. If you want to read that in, you say scanf, and then give it %s, as he said. %s says, I'm reading in a string of characters. Now, if you look up the documentation for scanf, what you'll see is it actually stops on white space. But you can give it other things to make it stop on different things. But it will stop on the first white space. What is white space? A blank, a space bar key, a tab, or a return character, or a new line character. That's what white space is. Well, look up the documentation for scanf. Read it. It'll be good for you. Right? Again, those of you that go home, we'll see who actually reads it. It will matter when you take the test in 2 weeks. 2 weeks? 2 weeks. Because understanding the why helps you succeed in that test. Okay, so what do we put for the variable? Remember, we need to put a reference to the variable. So, if you put a reference to the beginning of the string, the beginning of this array is where? Who's next in the list, in the line? We'll start with you. How would you say the beginning of array S is? Take a guess, it's okay. I don't expect you to necessarily know. You can't freeze. You cannot freeze. Because you're going to be at home doing your homework assignment. You freeze, where do you go? Where do you go from there? Right? You cannot freeze. You have to make a guess, an attempt, and work on it and go from there. This is how computers work. This is how computing programming works. You cannot freeze. Sometimes you need to get up and go get a cup of coffee and then come back, right? Clear your head a little bit, but you cannot freeze. So guess, what do you think you put? Guess anything. The name of the array is S, so guess anything. We're going to stand here until you guess something.
Chair.
Say again?
Chair.
2? What did you say?
I said chair.
Chair? Care?
Yeah.
Like C-H-A-R?
Yeah.
Like this? No, it can't be that. So, remember arrays start at index 0? So S of 0 is the first entry in the array, right? And we also know we have to give a reference to it. So we put my poorly written ampersand there in front of it. That will work. But there is yet another way. You can just put S there because S is the reference. If you go to the stack where S is located, that is the value of the memory address, which is what you want. What you want to give it. To say where to put the input. Make sense, I hope? Because you're giving it the value of S without it being subscripted, so you're just giving it the memory address, which is stored in the stack. But if you say S sub 0, it's going to give you the value of 0, but if you put the ampersand in front of it, it's going to say, give me the memory address of S sub 0, which is the same thing. Both of those are saying absolutely the same thing. Okay?
Is that also only because S is not defined yet?
S is defined.
Or sorry, assigned.
It doesn't matter if it's assigned or not. Because when you declared it here, right, in straight line code, we'll get to more complicated things in 2 or 3 weeks, right? For the straight line code, here S sub 20, you've defined it, and it's allocated given space. Whether you put, if I said S sub 0 gets 5, before this, it wouldn't matter at all. Whereas this is a character array. S sub 0 gets single quote A, single quote, it wouldn't matter. Just have a value that you're going to overwrite one way or the other.
What happens if you put S sub 20?
It would start, I mean, suppose I put, suppose I did this. Suppose I did that.
Yeah.
Unfortunately, the C compiler is not going to object, nor will the runtime object, but it's going to stomp on memory that starts right at the end of the array S. Because S sub 20 is the very next memory, memory address after the array.
You always want to start from again.
Typically, I mean, it's possible you would want to read into the middle of an array. I can conceive of reasons, but we're doing simple things here, so yes, for simple purposes, you always want to start at the beginning of the array. Okay.
So, since, sorry, I'm like trying to phrase this. Since it like
ends on the white space, like if you were looking for someone to type in like their first and last name, you would only get their first name when you're scanning the first string, right? So if you wanted to get someone's first and last name, you'd have to have two separate variables, one for the first, one for the last.
Yes. Or you could do something clever and say, we're going to take 10 characters of his first name, if it's more than that tough, and then you just do what he said, start in the middle of the array, that works fine, ampersand S sub 10, and then take the next input if you want to do it that way, that would work. And also, you can give other parameters to the format specifiers to further refine what it's doing, to say how to take how much. And go read the documentation for scanf. I'm pretty sure it stops on white space, but make sure. Because this, remember, this is a fairly rudimentary input system. It's just doing the formatting for you as best as it can. And because scanf is defined to end on white space, there may be other modifiers you can apply to the %s format specifier to make it do different things. You can look those up. But for our purposes in just writing these simple programs, this will work. This will get the job done. But it never hurts to look for the more complex things, right? In other words, do the immediate simple thing, make sure it all works, right? And then, because you're going to be curious, go explore. That's how you become a programmer. The world of what if. There's a Marvel series called What If. I think it was animated, right? It's interesting. What if? Those are good questions. Spider-Man girl knows about what if. She had a Spider-Man shirt on the other day, so I asked her who her favorite Spider-Man actor was. I don't have a favorite. They're all sufficiently different that, anyway. To be a programmer, you have to have some piece of you that's a nerd. Sorry, it helps. Some of us learn to hide it better than others of us. I hide it depending upon the situation I'm in. At high-class executive dinner parties I'm occasionally forced to go to, I hide it very well. Are you sure you're an engineer? Oh yeah, I'm an engineer, sir. Then how do you know about all these other things? Well, I'm a well-read engineer. Anyway. Strings, that's how they work. Oh, by the way, when it reads that string into your variable, scanf will put that terminating null character for you. So that's just what it does. That's just, if you go look up scanf in the documentation, it'll say, oh, by the way, we stick the null termination character there. So that when you use it in all these other libraries that are expecting a terminating null, it'll work right. It'll seem like magic, but there's no magic. Somebody wrote code to do that. A long time ago. Right. Okay, any questions so far? Okay, the last thing is you will sometimes get warnings when you use scanf. It will say you're insecure and all sorts of things. So it'll say you should use scanf_s. I think the _s means secure form of scanf, because what it does is you have to provide it an additional variable behind when you're doing something of indeterminate length, like when you're doing an integer or a float or whatever. That's not indeterminate length. It's well specified what you're getting. But when you're doing something of indeterminate length, like a string, to use scanf_s, you have to give it comma a number, or a variable that contains a number that says what's the maximum input. And that's a security thing. So it stops buffer overflows and security holes like that, stomping on other people's memory, and which is a security hole. There's all sorts of security holes. So that's what scanf_s does. It if you get a warning, it'll stop that warning, right? But for our purposes, using scanf is going to be good enough for what we're doing. Questions? Sir?
You said scanf_s is like a secure form for scanf.
But you also have to give it slightly different parameter list.
What's, like, you said it's a secure form, so what do you mean by that?
So in security, hackers, everybody's heard of hackers, right? Russian hackers are coming, like the British are coming forward now. Well, Colonial Pipeline. This is the pipeline that runs up and down the East Coast, moving oil, right? Moving oil, gasoline, moving all sorts of different things that we stick in cars and heaters and all sorts of things, right? And it's the only source. And it goes up here and diverges out. When it was hacked by Russian hackers, well, Eastern European hackers of some flavor, I forgot if it was Russians or whoever. You know. When I say Russians, I mean Russian people who live in Russia. It might have been hacked by Americans, people who live in America. Not pejorative on Russia, right? It's where they happen to live. They hacked it. They encrypted the computer systems and said, give us 5 mil and we'll give you the key to unencrypt your system. Right? So that's a security hole. That's a security error. They had egg all over their face. And I think they ended up giving them $1 million or gave them 5 and got 4 back or whatever. Right? But they were, the hackers were successful to some extent. Okay? How do you hack things? There's lots of different ways to hack things. Before I went to work for CoStar or Apartments.com, I worked for another company called Fiserv. Fiserv, if you everybody have a bank account, most people have a bank account. You do online banking. None of us walk into banks anymore. I haven't been inside of a bank in a very long time. Right? You do online banking. Fiserv provides the front end for that online banking that that a lot of financial institutions use. Right? A lot of credit unions, a lot of whoever. Right? So, Fiserv foolishly said, okay, we clean up all the security holes, we're good. And then they didn't look at it for 2 years. Well, you know what? Hackers are busily finding other ways. And programmers are writing insecure code in that 2 years. So my job was to lead a team of people to go clean this mess up. Right? And you run scanning tools that find programming errors. It has lots of false positives. That's the problem with it. But real negatives, right? Real things that can be issues. So one of the ways that you can hack a system is to manage to overwrite something in memory with a specific piece of your code that somehow starts getting executed. Then you found your way into that computer and you can expand from there. So that's one of the ways. This is the buffer overflow exploit, right? There are other exploits called buffer underflow, which is an entirely different beast. This one happens to be buffer overflow. The buffer overflow exploit for security reasons.
All that is using the scan_s, right?
Yeah.
And you said something about like insecure code. Like, did they just write the code poorly? Is there such a thing?
Oh yeah. There's a lot of poor code written out there, right?
How would it even like work if it's poorly?
It's not poorly. It's insecurely, right? We can talk about that till the cows come home. If you want to talk some specifics, stay after class, and I'll give you a few examples. Okay? But this is why scanf_s came to be, because of what hackers could do. Now, hackers aren't doing a lot against C programs anymore, but a hole is a hole. You still got to close it. Questions? Okay, we didn't get to conditional expressions. And I had more on my list. I just ran out of board space. That's where we'll start next week. Do your homework. Work hard. Think. Ask questions. Look up things. Have a nice evening. See you next week.